we call this a complex fraction equation. And we're supposed to find natural number solutions, A, B, C, and D. Y'all, in natural numbers, I do mean just the set, just the counting numbers. The natural numbers are the set 1, 2, 3. I'll put an ellipsis here to connote ad infinitum. Okay, so just the counting numbers, 1, 2, 3, 4, 5. All right, so on. Now, so we're given this expression. On the left-hand side, we have 105 over 17 is equal to this, I guess, nested or continued fraction, they call it. And there are 3 unknowns, A, B, C, and D. And often if there's one equation with 4 unknowns, you're not going to get it solved. But we have the structure, I guess, of the division algorithm to help us out right here. Now, a fact that comes into play, and this isn't very much, I mean, you can see exactly what I did here. But a result that I'd forgotten when I tried to work this is like, if, let's say you have this circumstance here, 1 over A, where A is just, we can say a natural number now, or any real number, I suppose. If 1 over A is equal to B over C, okay, B over C like this, just by properties of equality, if you cross multiply CA and AB right here, you actually get that this is equivalent to, I mean, this can only be true, this left-hand side of this logical equivalence can only be true if this is true, A, and I'll just, for grins, I'll write it A over 1 if you want. You don't have to, but you can write it A over 1 is equal to C over B. You can see that's more of a property of equality than anything else. You can use reciprocals, the language reciprocal if you want, but it's just a cross multiplication here again. C times 1 and A times, I mean, just if you cross multiply and divide, you end up getting this statement right here. And it's more commonly just written as A is equal to C over B. And that's exactly what happened right here. We use that property 2 or 3 times here. If you divide 17 into 105, you get 6 with 3 left over. And so by inspection, that means that A has to equal 6. All right. And then 3 over 17 has to be equal, this 3 over 17 piece has to be this part right here, this entire part right here. But now we use that reciprocal property. 1 over an object equals to this fraction means the denominator of the object is equal to this fraction inverted. Okay, which is exactly what we're saying right here. Okay, all right. And now the process begins anew. If you divide 3 into 17, you get 5 with 2/3. It's 5 and 2/3. And so again, we set 2/3 equal to this piece right here. Okay, we set 2/3 equal to that piece right there. But we use this property again. That means that C plus 1 over D is 3/2. Okay, and so on. And it's almost better if I don't talk, right? You can just see what this is all about. Anyway, these are the solutions. A equals 6. Let's see here. We got B equals 5. Sorry, B equals 5. Cross through the B there. And then we have C equals 1 and D equals 2. So we solved one equation with 4 unknowns just by what you would call, I guess, the division algorithm, or just dividing the natural number into the larger natural number. Okay, I hope you guys enjoyed that.